Great. So, hello from Tel Aviv. My name is Amit. I think I'm now facing the most challenging technological task ever, dealing with Microsoft Teams. So let's hope I'd be able to share my screen. Let me know. Yeah. So, do you see my slides? Great. So we're going to talk today about AdBay and the AdBay case study and how we used Dapr to improve our operations. We have published this case study under the CNCF case studies blog, and you're most welcome to go there and read for further information. So we're going to talk about AdBay as a business. I'll give you a tech overview about our tech stack, why we went with Dapr, and the journey we had in adopting Dapr. So a little bit about myself. My LinkedIn handle is Amit Mor 1. If you're not selling anything, you're most welcome to connect with me. I'm the software architect of AtBay for the past 2.5 years. AtBay is about 6 years old, around 300 people, 80 in Tel Aviv, and half of those are engineers. We had 4 rounds of funding where we been funded in a total of about $300 million. Lead investors, let's give them the respect. Lightspeed, Icon Ventures, Shlomo Karim and Kumra, and M12 of Microsoft. So we got something here. Adway is an insurtech company specializing in cyber insurance. We have other product lines, but this is the biggest. And cyber insurance for SMBs means that we try providing small and medium businesses with some sort of contract or liability in case they were attacked and breached. And the problem with SMBs is that they often lack either the technological awareness and the security awareness, as well as the finance to buy themselves a proper enterprise grade and operate a proper enterprise grade security solution. So I think what I've read like a few days ago is that the presumed median ransomware, which is the most common attack nowadays in the past couple of years. So the median is around $140,000 in the US. That can take a small business out of business quite fast, and the numbers show exactly that. So our mission is to improve our policy holders' security, and when we do that by providing them with security reports, as well as the fact that we continuously scan our entire portfolio. And in case that we find some sort of a vulnerability, or we find out that there is a new vulnerability in the wild, and some of our customers have this vulnerability, we actively interact with them or with their insurance broker and try to work the issue out with them. And this is quite uncommon if you think about your daily interaction with your insurance company. Most insurance companies don't interact with their customers unless it's to talk about renewal of the policy. Post-breach, we try to provide good service. We provide our customers with forensic services, with data recovery tools and teams. We handle claims, and of course, we compensate our customers. But we have a broader, bigger mission, and it is to have a positive impact on the actual vendors that provide the software tools for those SMBs. And this is not something unprecedented. This is a snippet I took from an article that says basically that one of the drivers towards general adaptation of airbags in the car manufacturing industry is insurance. And if you think about it, that makes sense. Insurance companies don't like spending money if they can save it. And of course, the customers benefit from having better safety measures. So the same goes with software vendors. We reach out to them, we work with them. We have like the real information about vulnerabilities that are used in the field, not just the theoretical zero-day vulnerabilities that we hear about over the media. We actually hold the data to what happens in the field, and we have enough customers to be significantly in terms of statistics. So as a result of that, what we can publicly say is that our portfolio companies have fivefold, 5 times less cyber events and breaches in comparison with similar companies in the wild. And this is like the tip of the iceberg here. We try to be better than what we are now, and our next products would, I hope, improve our customers' security even more. So let's talk about tech. We are hosted over AWS. We use EKS. We have like around 20 clusters. Most of them are volatile, meaning developers can spin up like the entire ad-based stack for them to use and then to destroy. We have a couple of stable environments, you know, the usual stuff, demo, staging, production, etc. We use all sorts of databases. We use Redis, or on Amazon it is called Elasticache. We use Elasticsearch, which is called OpenSearch on Amazon. And we use all sorts of relational databases using Amazon Aurora, and we have graph databases. We also use message brokers such as the Amazon SNS, SQS, and the managed Kafka solution over AWS. Our main development language is Python. We also have a few services written in Go, and I have a warm place for Nginx and Lua, so you can find it somewhere in the system. So we try to adhere to a couple of principles. I'm just outlining 2 of those. So we try to adhere to RESTful API-driven design. That means that if one wants to create some sort of a business logic to create a microservice, the first step towards achieving this goal is defining an open API spec and having a conversation with the stakeholders and the clients of that service, just to make sure that people do talk with each other before they start writing code. And we surround those contracts with all sorts of code generation tools to enhance our developers' productivity. So they don't need to focus on boilerplate, test harnesses, database connection, matrix, login, all those things that can take up like their time. So why are we talking about Dapr here? What's for an Israeli startup to use Dapr? So as I said, we adhere to RESTful APIs, and that goes for both microservices that manage resources, the classical REST API. You have a resource, you change the resource state transfer, and this is like the top piece of the image here. But on the other hand, we have many asynchronous operations. For example, if somebody wants to create a policy or ask for a quote, most likely for cyber, we would start scanning and calling other third-party APIs, and usually we do that asynchronously. But still, we use a dispatcher. The dispatcher here manages a resource that you can consider as a job or task, job and tasks, so that the client won't even know that asynchronous activity is going around. But still, behind the scene, the dispatcher needs to communicate asynchronously somehow with the workers. That's what I'm calling here the async wilderness. Because before we started using Dapr, we had many many things that we've created on our own, and I'll talk about them in a minute. So if I'm trying to focus the problem area here is the async wilderness. What approach is best for us? What would we choose to use? So, sorry. So the challenges is how should the asynchronous components communicate? And we have devised a list of criteria. So the first one, which I consider as one of the most important one, is no significant paradigm shift, no major refactors. And you often see that when you start working, for example, with message brokers, suddenly you start implementing not only HTTP behaviors, you start working around dedicated client libraries with their own issues. And we have a really busy system, and we didn't want to force a major refactor throughout the entire system just to enjoy a better engineering behind the scenes when talking about async. The second critical parameters as we see that is the differences that you often see between local development and cloud-based environments. I think it really blocks or adds too much friction to the development process. We still are in an era that local development wins, and we prefer that people would do as much as they can locally, and when they feel secure enough, they can move, as I said, to their own dedicated environments, and then from there continue to the more mature testing and production environments. So if we were to consider message brokers as our asynchronous mechanisms, again, we wish to be provider agnostic somehow, because I don't think that there is just one solution that fits all scenarios. And often you see like a big mishmash of client libraries hidden behind big shared utils libraries, and I'm talking about it just 2 bullets below. And this becomes in itself like a distributed monolithic library that forces the entire company to upgrade, to roll out in case some critical issue has been found in that library. And again, we wished not to reach that place. And the ETC here is not really an ETC. These are like strong points. If we are to go with something that does the async magic, it should be performant and fault tolerant, robust, scalable, and traceable. Visibility is critical for us. That's why we use REST APIs, because of the plethora of tools that allows us to better understand what's going around in the system. So I'll just run through that. You probably all know the possible solutions, except maybe Dapr. It's not in the list here. So we're talking about in-process concurrency, but it's not durable, crashes, stuff like that happens. Directly using message brokers, queues, Kafka, Rabbit, them too, I guess. I'm calling it MQs++, meaning some sort of an orchestrator over the message brokers, or some frameworks in the Python world, it's Celery. Or to homegrow your own library or homegrown your sidecar. I did both, and I didn't really enjoy either. So why Dapr, or why Dapr PubSub? So I'll just run through what Dapr PubSub does in case people don't really know the PubSub component. So in the PubSub component of Dapr, what you get is immediately what we strive for. We wanted to abstract away the infrastructure, meaning that you have your application. Your application works with the Dapr sidecar on the left hand here as a publisher. It has its own app ID, and it pushes messages to the sidecar, totally unaware of the underlying infrastructure. The sidecar uses the appropriate component that it is configured to use on that particular PubSub. It pushes the messages, or and pushes them to the infrastructure. And on the right-hand side, you can see a subscriber, a Dapr sidecar acting as a subscriber, pulling messages out of the infrastructure, again, with the appropriate component, and pushing it to the services that act as subscribers. So what we get here is as listed here. First and foremost, it abstracts away the infrastructure. It doesn't really matter if you're using Redis, if you're using SNS SQS, if you're using Kafka. Basically, the code does not change. And as I said, we didn't want paradigm shift, and this fits us beautifully. Easy to start with, great documentation. There is a RESTful API for the sidecar, as well as gRPC and SDKs. And of course, OpenTelemetry works for us well. So let's continue. So we kind of by accident ran and found out that Dapr exists, and the Dapr PubSub list of components, I'd say, exist. So we are working, we are hosted over AWS, and we have several services already using the SQS service, which is the queuing service over AWS. So what came to mind is to use the Dapr PubSub AWS SNS SQS component so that it would integrate with the already existing SQS usages. So again, I'll try to give you some sort of a quick tour around what the component does and what's the relationship of SNS to SQS, and why is this the right pattern as Amazon recommends. So on the left side, we have a cube, a publisher. The app ID of the publisher is called wow, as far as Dapr sees it. When the publisher pushes a message to the sidecar has ability to provision the resources over AWS. So it would create a wow topic over SNS. SNS is the PubSub service over AWS. And once you have a subscriber on the right-hand side, for example, subscriber A subscribing to the wow topic, then the component would create an SQ dedicated to any application that identifies itself as A, and would form a subscription between SNS and SQS, meaning that SQS acts as an applicative subscriber as far as SNS knows. And when a message lands on SNS, the infrastructure pushes that message to SQS. And from SQS, Dapr pulls messages and pushes them to the subscriber according to the configuration. Another nice feature that SQS has is built-in support for dead letters queue. And that means that if a message is received more than a given threshold, after that threshold, the infrastructure AWS would automatically move that message to the dead letter queue. So I'll give you the tour de force, the round one of the fight between an architect and the system. You know, you sometimes find yourself like battling with technology, and this was no exception. So at the honeymoon phase, we had Dapr running locally, using the PubSub tutorial over Redis. I've written a small dispatcher code, kind of mimicking the behavior that I've shown you before, and a pair of two kinds of workers, and knockout, all good and great. I was really happy it works. But then on round two, on the phase that I think this might work somehow phase, I've moved to actually test out how the PubSub SNS SQS component works. So I've deployed Dapr on EKS. I've used the documented configuration for the component using AWS access and secret keys, which you can consider as an authentication mechanism. And again, deploy the dispatcher and workers. The result was, unfortunately, that no resources had been provisioned by the sidecar, and no sign of anything actually happening. I'll cut to the chase here. At the end of the agony, the conclusion was that when you use EKS and you give your nodes roles and policies, um, so if you use your own access and secret keys, there is some sort of a collision there. Uh, I haven't still gotten to the root of that, but there is a collision there and nothing happens because basically you haven't been authenticated correctly with Amazon. So as a result of that, we have fixed the documentation to indicate that when moving on to EKS, do not use do not use access and secret keys if you have pinned roles and policies to the EKS nodes. So round three, I was really happy. I thought I figured it out. Look no hands ma phase, riding my bike, Dapr on EKS, no access key and secret key, but the result still was a bit shameful. At least no resources were provisioned, but we got some clue that there is something else going around because we had all sorts of authorization related errors, and that kind of gave us the hint that we didn't use. Once we identify which policies we should change, then we understood that the policies we gave the sidecar were too narrow or incorrect. And as a result of that, again, we have now fixed the documentation for other people's sake. Round four, the why is this thing not working? I've started like being really itchy there. Uh, so this is like me trying to figure out what's wrong here. So I've like removed the workers and said to myself, the only thing I want to see is a message landing on SQS, meaning it passes through SNS and using a subscription, it arrives to SQS. So again, correct IAM policy and roles, no access and secret key, but no workers this time. Luckily, I saw the SNS topic being created by the sidecar, which was great, but no SNS, no SQS queue. So this is like asking yourself a Zen Kuan, which is what is the sound of a one hand clapping? And I'll try to explain it in the next slide. And I think the next slide is the biggest takeaway for anyone considering using the SNS SQS PubSub component, because this is like the stuff that we teach developers here. And apparently we didn't understand when SQS is being created because evidently it wasn't created. So what's going on here? What's going on? So we had a system where we didn't have any subscribers. Basically, we just had, and we didn't have a subscription CRD as well. So we had just a publisher, and as the sidecar sees a publisher publishing a message, its default behavior is to see if there is an SNS topic. If not, it creates the SNS topic. It does some sort of topic sanitation, never mind that. But it creates a topic and pushes the message. That's like the publish side of the sidecar. And the reason why it doesn't create the SQS queues is very simple. SQS queues are created based on the subscriber, based on this identity of the subscriber, because they are dedicated per subscriber group. So if you don't have any subscriber or you didn't define a subscription, there is nothing to create. There is no subscription created. There is no queue to create, and your messages won't be received anywhere. So to avoid that, you either have to define a subscription and deploy it so that when the sidecar boots, it has the subscription and it automatically creates the right resources, or you define a working subscribe endpoint on your subscribers. Otherwise, you won't see SQS and subscription and messages. So round five, we are almost done. Don't worry. The round five, the this must succeed phase, because there was a feeling that we are starting to understand what's going around. And indeed, by adding a subscription configuration, we were able to set up the system. Everything worked. It was beautiful. But unfortunately, don't call me greedy phase, I also wanted, because I promised that Dapr is also something that would help us to be more elastic. So we added Kata to the mix, and we configured Kata to monitor the size of the queue over SQS, and scale up and down the system. So scaling up worked beautifully. We added a little bit of pressure, and then we let the system cool down and scale down. But the unfortunate thing that happened when the system scaled down is that messages stopped being received by a subscriber group that was scaled down, meaning if I have a couple of pods running as subscriber A, when one of the subscribers went down because of scale down, the entire messaging flow was broken. So eventually, after digging everywhere, we got to the conclusion that there was a bug on the close method of the PubSub of the SNS SQS component, and there was a mistake there when one sidecar and application are going down. The close method is being called, and within that method, there was just a deletion of the subscription, meaning that the SQS queue was present, the SNS topic was present, but there was nothing to connect between the two because of that bug. So we filed for an issue with the components contrib, and this is our first contribution that we made to that component, and the fix was released on 1.4. Following that, we saw that the community is really welcoming and the process is really fast and welcoming. So we added for a couple of more contributions, mostly revolving around stability and maturity, meaning bug fixes, topic and queue name sanitations, conformance tests to promote the component into beta, documentation, security, added context and timeouts to every AWS related operation. And we added a feature which was and still is a very important feature for us, and it is called Disable Entity Management, and I'll talk about it in a second. Further contribution were around pure SQS features, taking advantage of the FIFO queue that SQS has if you want to, and as I said, configuring SQS with the DLQ internally, not something that's related to Dapr as a runtime. And subscriber features, we are accepting like the resiliency spec, and one of the latest changes we've made is to the concurrency mode, and I'll say a few words about it. When you pull messages from SQS, you pull them in a batch. The maximum size is 10, but once the sidecar has those 10 messages, it now can send those messages either one at a time, serially, in a single mode, or it can send the 10 messages concurrently to the subscriber, and this is the parallel mode, which is the new default for the SNS SQS component. So just to summarize, 1 year later, we have experienced easy migration to use PubSub, no significant paradigm shift. We experienced fast developer onboarding. It simplified as we wished, it simplified our development of asynchronous processes. We had 0 crashes, and this is a big kudos to everyone contributing and maintaining the project, 0 crashes and errors. And of course, we enjoy OpenTelemetry a lot because we gather everything over Sumo Logic, which supports OpenTelemetry. So internally, as I said, the disable entity management feature. So what it does basically is prohibit or make the sidecar, the component, not provision. It stops the component from provisioning resources over Amazon, and this is something we wish to do because our production environments are provisioned using Terraform and other scripts, and we didn't want to give those permissions or split the logic between Dapr and the GitOps operations. So the disabled entity management just forces you to have the topics, the subscriptions, the queues already present and configured, and Dapr doesn't try to create those. Also, we are working on creating, we already have an HTTP-based SDK because Dapr's SDK communicates with a sidecar with gRPC. And as I said, we have a lot of stuff that we build around HTTP, mostly around testing and visibility, and we needed some sort of a thin API, thin SDK for the stuff that we do with Dapr. I'll skip through those. You can read it on your own time. We use several other components now, states, output binding, service invocation, and we are moving toward using Dapr lock. So final thoughts. Dapr delivered almost everything we opted for. Still, upgrades are painful for us. You need, full system rollouts to be injected with new sidecars or changing the control plane is painful. We really enjoy Dapr components code base and the components development model. And I want to thank here the community, all the very patient people helping me out in PRing and asking questions. So thank you for the vibrant and responsive community. And that's it. Questions?
Are there any questions that people would like to ask Amit? Well, we've got him on the call here. Maybe Amit, one thing I'll just kick off. What are you planning on using the? What are you planning on using the distributed lock for?
Hello.
What are you planning on using the distributed lock for in future? Do you have a plan for that?
Yeah. We have many. We are internally like starting to work to use workflows and orchestration and locking and stopping flows is something important for several business workflows we have. For example, you don't want to quote a policy if you haven't finished some sort of security check. So we need some sort of a distributed lock so that the system would know that it shouldn't proceed doing what it does.
Yes,
Hello, can you hear me?
Yeah, although you're blurred out. Yeah, now I see you.
Okay, so my question is, what are challenges when you upgrade Dapr?
So first of all, you lose the control plane. So for a little while, your sidecars are kind of disconnected with the control plane. On the other hand, it's the same issue. Like you've got a really central piece in the infrastructure that you use. In that case, it's Dapr. And you need to upgrade it. So to be injected with a fresh version of the sidecar, we roll out our containers, our pods, basically, to get like a new version. And of course, we need to think well about draining in-flight messages that are already within the sidecars and to do all those restarts in a reasonable manner somehow. So I can say that also there is like a sort of independence between actual deployment and the CRDs. So if CRDs have been changed, you get like a period of time that the CRDs are not updated, and we need to update them like separately. Thanks. Thank you. Thank you very much. My pleasure. Bye bye.